right, everybody, we are going to get started with this last free response question for today, which is 2005, number one. So, number one is dealing with, we have this back-to-back STEM plot, and we're dealing with urban students versus rural students and look at their daily calorie intake. Part A says write a few sentences comparing the distribution of the daily calorie intake of ninth graders and students in the rural high school with the distribution of the daily calorie intake for ninth graders in the urban high school. So anytime we're comparing this, two different groups like this, could be a back-to-back STEM plot, could be two different histograms, it could be box plots that are stacked up against each other, just like we did in the last two free response questions. You want to think about it in terms of socks, especially if it's asking a specific question like this, comparing the two different distributions. So we want to think about center, shape, spread, and outliers. And when you want to think about what specifically is given to you in the graph. So a big benefit of having a STEM plot or back-to-back STEM plot is that you have the specific data points, so you can calculate any summary stat you want because you have all the data points. Whereas if you have the histogram or a box plot, you don't know what the specific data points are. So what I went through and did is I put on all those values into list number one, list number two in my calculator. I ran one variable stats, and then I wrote down summary stats that I wanted to use to compare that. So you want to write down one form a center, one form a spread. I ended up going with median or quartile range just because it was just a little bit easier. The mean and standard deviation, which you could have also used, to come out some long decimals. So I ended up using the median and interquartile range. You didn't have to write this down, the actual values on your paper to get full credit, but I wrote them down here on the bottom before I wrote my response, just so I could use that and reference it as I'm writing my response. So we go back and look at the graph right here. First sentence we want to talk about is comparing the summary sentence and context. So we can see the rural students have a higher calorie intake than urban students. So that's what we want to include as our first contextual sentence. So based off the back-to-back STEM plot, it appears rural students have a higher calorie intake than urban students. Okay? So again, you could, if you had that sentence, that's basically describing what the graph is. So you give that to anybody you know, as long as if they know anything about statistics, they're going to understand what that statement means. Okay? So start off with that. Then we're going to use the rest of the paragraph to back up our claim, talking about all the different components of SOX. So next sentence, rural students had a higher Q1 median in Q3 than urban students. So I'm using data to back up my claim for that, using the center and then also Q1 and Q3, which form a spread. Rural students had more variability. And for this one, you didn't have to actually use the specific values. But if I wanted to, I could say the interquartile range for the rural was 10, interquartile range for the urban was 7. Remember, just do Q3 minus Q1 to further back up my claim. But you didn't have to include specific values for this question. Usually, anytime you're comparing two different distributions, you don't have to write down the specific values of each one. You just need to write down which one's higher, which one's lower. Whereas if we were just looking at just a regular STEM plot with not a back-to-back and just one set of data, you'd probably want to write down the specific values. Then the next question, the urban students are skewed towards the higher values. So let's go back and look at that graph. Remember, this is a little bit tricky with the back-to-back STEM plots because the left side's kind of like backwards of what we normally look like. So instead of saying skewed to the left or skewed to the right, say skewed towards the higher values. Because even though if you looked at it kind of like on its side, it'd be skewed to the left, but since it's backwards, just because of the nature of this back-to-back STEM plot, that's going to be skewed towards the higher values. So you say the urban students are skewed to the higher values, and then the rural students are roughly symmetric because the shape's roughly symmetric. And then you say neither appear to have outliers. So you can see that there's no apparent outliers because everything's pretty clumped together. There's nothing, no data points. They're off by themselves. So that's what you should have done for part A. You're including talking about the shape, center, spread, outliers, and then you're also including context. So not only do I have that first contextual sentence to start off with, I have little contextual things where I'm talking about the rural students and the urban students throughout the rest of my response. So even if you can just include the population groups in your response like this, the rural students, urban students, then it's going to include more context and make your response stronger. On a lot of your responses from Monday, you were just saying the mean is higher or the interquartile range is higher. You're not even talking about the population groups. So want to make sure you're including those population groups context into your response while still making it concise. So I included all that. I think that's only like 4 sentences. Only take up about, let's tell me that, 6 lines. So it's not like a super long response. Again, you only got 12 minutes for each of these sections. So you want to make sure you only spend about 3-4 minutes per part if it has 3 parts like this. Now, part B, is it reasonable to generalize the findings of this study to all rural students and urban 9th grade students in the United States? So it is not. You should have said no to start off. And the reason is because they only took 1 high school from the rural students and 1 high school from an urban community. Okay? So anytime we're only taking just 1, it's not going to be a generalization for the entire United States. If we wanted to have it represent the entire United States, we want to randomly select 50 high schools, that probably from each group that are randomly. So that way we're including for different types of rural communities, because rural could be up in the mountains, it could be out in the desert, a lot of different factors that could influence their calorie intake. And then same thing with urban. People in the city in New York City could eat a lot different than people in Los Angeles. Okay, so you want to make sure that you're including a lot more schools in your sample to account for that variability. So if we kept the study the way it is, we could only say this generalizes the results for the students at these 2 different schools. And in real life situations, that's why you have to read studies that are in like articles very carefully, because they'll have a study like this and they say that rural students have a higher calorie intake, but if you're only looking at 1, if you look at the fine print, they might have only looked at 1 school in each group, which is not good sampling techniques. So let's look at my response I wrote down for that. So I just said no because they only used 2 schools, so the results can be only generalized for those 2 schools. So it doesn't mean that the whole studies, we can't use anything from the study, we just have to put that disclaimer out that we can only generalize these results for the 2 schools that we looked at. Then part C, it gives us these 2 different plans and it asks us to select which one would be the best one to use. So plan 1, you're having the students track just for 1 day. And then plan 2, you're having them tracked over the same 7-day period. So you should have put plan 2 as better because it includes more days, which accounts for variability or like potential outliers that could really influence our results if we only looked at 1 day. So for example, if we use plan 1 and let's say the rural school has a day where they just gave out free pizza. So that high school, on that day, they're probably going to have pretty high calorie intake because they're just giving out free pizza. But that's not normal. But if we're only including 1 day in our study, and if it's randomly selected, we could have taken our data points on that day, and that's going to kind of make our data meaningless, right? Because we're taking data on a day that's an outlier. But if we take it over a 7-day period, then even if that day, the outlier day where they get free pizza is included in our 7-day period, then it's kind of counteracted by the other 6 normal days that we included in our study. So it accounts for that natural variability. In general, anytime you include more data points, in this case more days, is going to make your results a lot more accurate because it accounts for that variability and helps eliminate the effect of potential outliers. Again, short response for part number C. Plan number 2 would be a better design because it includes more days, which would help account for variability between the different days. All right, so that's what you should have had for that response. As long as you picked number 2 and had a good justification for that, you have gotten full credit. Same thing for part B. As long as you had you said no and had good justification for it, we've gotten full credit for that segment as well. On part A, you should have been including center, spread, shape, and outliers, and also context to get full credit for part A.